Our lesson today is to be able to write inequalities and to be able to represent situations using inequalities. The essential question: how can you use a number line to represent solutions of an inequality? Well, what do we mean by an inequality? It is a math sentence that compares expressions. It contains the symbols less than, greater than, less than or equal to, or greater than or equal to. To write an inequality, look for the following phrases to determine where to place the inequality symbol. All right. Key phrases that represent less than is less than and fewer than. Right? We would use the less than symbol in those cases. We would use the greater than symbol if we see the terms or the phrase greater than or more than. Less than or equal to is at most or no more than. Right? Those are the key words or phrases that would represent less than or equal to. And greater than or equal to would be least or no less than. All right? Let's take a look at some examples. Our first example, we want to be able to, or we're given the following situation. A number q plus 5 is greater than or equal to negative 7 and 9/10. Write this word sentence as an inequality. Well, I'm given the number q, and then I'm told to add 5. That, we are told, is greater than or equal to negative 7 and 9/10. Right? That is how we would write that word phrase as an inequality. All right? Try a couple more. A number x is at most negative 10. Well, if you have to, you look on the previous page for the inequality symbol that represents at most, right? So why don't we go back and do that? At most. Where did we see at most? Oh, at most is associated with less than or equal to. Right here. At most is associated with the less than or equal to. So I come back here and I know that I'm going to be using the less than or equal to symbol, and then I'd have negative 10. So a number is at most negative 10. At most meaning it can be no more than negative 10. It can be equal to negative 10, but it can't be more than. Next example. Twice a number y, so 2 times a number y, is more than, so that's greater than, negative 5 over 2. All right, so very simple. The key phrase there is more than. More than is associated with the greater than symbol. All right. Now, we have a solution of an inequality is the value that makes the inequality true. An inequality can have more than one solution. The set of all solutions of an inequality is called the solution set. So when we want to check to see if a value is a solution of an inequality or not, we have to replace the value in the inequality with the value that's given. So I want to replace the variable with the number. So here we want to know, is negative 2 a solution of this inequality? So we replace negative 2 with x, we add 2, and that's going to give me 0. Is 0 less than or equal to negative 1? Right? And the answer to that is no. So that means negative 2 is not a solution of that inequality. Let's try negative 3. Replace x with negative 3 and see if we get a statement that's true. Negative 3 plus 2 is negative 1. Is negative 1 less than or equal to negative 1? Yes, it is. So that means that negative 3 is a solution of that inequality. Let's try the value of negative 4. If I replace x in this inequality with negative 4, we add negative 4 and 2, that gives us negative 2. Is negative 2 less than or equal to negative 1? Yes, it is. So when we want to check to see if a value is a solution of an inequality or not, we replace the variable with the number. Okay? So let's try a couple of examples here. Tell whether negative 2 is a solution of that inequality. Well, I have a number y, take away 5 is greater than negative 6. And we want to check to see, is negative 2 a solution? So is negative 2, take away 5, greater than or equal to negative 6? Well, negative 2 take away 5, when we add the opposite, that's negative 7. Is negative 7 greater than or equal to negative 6? Right? The answer to that is no. Right? Negative 7 is not greater than or equal to negative 6. We try our next example with negative 2 once again. We have negative 5 and 5/10. times negative 2, is that less than 14? Well, what's negative 5 and 5/10 times negative 2? Well, that's going to be 11. Is 11 less than 14? The answer is yes. So negative 2 is a solution of that inequality. Okay? Try a few examples on your own where we want to check to see if negative 5 is a solution for these inequalities. All right, so we take problem 3. I'm going to replace x with negative 5, see if I get a true statement. So negative 5 plus 12, is that greater than 7? Well, negative 5 plus 12, that's going to be equal to 7. Is 7 greater than 7? The answer to that is no. Example 4, we have 1 minus 2 times. We're replacing p with negative 5. Is that less than or equal to negative 9? Well, doing order of operations, we have to do 2 times negative 5, which is negative 10. So 1 minus negative 10. Is that less than or equal to negative 9? Well, what's 1 minus negative 10? 1 minus negative 10, when I add the opposite, it's going to be 11. Is 11 less than or equal to negative 9? The answer to that is no. All right, let's try the next example. We have a number n divided by 2.5. Is that greater than or equal to negative 3? So is negative 5 divided by 2.5, is that greater than or equal to negative 3? Well, negative 5 divided by 2.5, that's going to be negative 2. Is negative 2 greater than or equal to negative 3? Answer to that will be yes. So when we're checking to see if a value makes an inequality true, we replace the variable with the number, and then we evaluate the inequality to see if we get something or a statement that is true or not. Now we want to learn how to graph the inequalities or to represent solutions using a graph. The graph of an inequality shows all of the solutions of the inequality on a number line. An open circle is used when the number is not a solution. A closed circle is used when the number is a solution. An arrow to the left or the right shows that the graph continues in that direction. All right, so very simply, let's start with y is greater than negative 8. If I'm graphing y is greater than negative 8, I start with a number line. Right? I always like to show 0 on my number line, and I know negative 8 is to the left of 0. Now, y has to be greater than negative 8, which means that y cannot be equal to negative 8, so that means I'm going to have an open circle at negative 8. I'm looking for the values that are greater than negative 8, so that means my arrow will go to the right of negative 8 onto the number line. When the inequalities are written with the variable first, the direction of the inequality symbol will be the same as the direction of the solutions, or the arrow that shows the direction of the solutions. All right, let's look at these next 4 examples. Okay, let's start with x is less than negative 1. I have my number line. I always want to show 0, and negative 1 is to the left of 0. We have an open circle because x has to be less than negative 1, which means x can't be equal to negative 1, and my arrows are going to go to the left. All right, so we have an open circle at negative 1, arrow going to the left. Remember, when the inequality is written variable first, the direction of the inequality symbol points to the direction of the solutions. Okay? Z is greater than or equal to 4. All right, have my number line. Here's 0. 4 is going to be to the right of 0 on the number line. We're going to have a closed circle this time because z can be equal to 4, right? Z is less than or equal to 4, so 4 is a solution of that inequality. And once again, z has to be greater than 4. The values that are greater than 4 are to the right of 4 on the number line. All right, problem number 8. Right, here's 0. Here's 1 4/10. It's going to be to the right of 0 on the number line. It's less than or equal to, so we have a closed circle, and my arrow, my solutions will be to the left of 1 4/10 on the number line. Right? It's a closed circle because s can be equal to 1 4/10, but it must also be less than, right? Less than or equal to. Now, example number 9 is a little bit different. I like to call these reversed inequalities. And why is it a reverse inequality? Notice that the variable is not written first. We have the number written first, and then the inequality symbol, and then the variable. Now, it's really important for students to recognize when they have a reversed inequality. All right? So it's going to start off the same. I still have 0. Negative 1/2 is going to be to the left of 0. All right? It's going to be an open circle because it's a less than, so I have an open circle at negative 1/2. But negative 1/2 has to be less than all of the solutions. So that means my solutions are actually to the right. When we have a reversed inequality, the direction of the inequality symbol will be in the opposite direction of the solutions. So it's really important to note when we have a reversed inequality because the solutions are going to be in the opposite direction. And very often students will make mistakes graphing inequalities when they have reversed inequalities. So you really want to pay close attention to that. All right? Well, that's it for the lesson tonight, right? Rather simple lesson. Hope everything was clear and that was helpful, and we'll see you soon.